Okay, so today we are going to talk about something huge, a change that's happening right now that could basically mean the end of trash as we know it. I mean, imagine a world with no landfills, a world where your garbage truck doesn't haul stuff away to be buried, but to be reborn. This isn't science fiction. This is the story of how technology is building a true circular economy.
But to get there, we have to start with a pretty stark reality. Our entire modern civilization, everything we build, buy, and use, is based on a system that has a single catastrophic flaw. It's a flaw that's big into almost every single product you own.
And this is it. It's called the linear economy. It's really that simple and that destructive. We take valuable resources out of the ground, we make stuff, and when we're done with it, we just dispose of it. We throw it into a giant hole. It is a one-way street from the planet directly to the trash heap.
Now, you can probably see the problem here. This isn't just wasteful. It's a system with a built-in expiration date. You just can't keep doing this forever on a finite planet. It is, quite literally, a dead end.
But what if we completely flip the script? This slide lays it out perfectly. On the left, that's us now. Take, make, dispose. But on the right, that's the future, the circular economy. It's make, use, return. The waste from one thing becomes the raw material for the next. It's not a line that ends in a landfill. It's a circle. It's designed to be regenerative, not wasteful.
And I want to be super clear here. This is not some kind of far-off utopian dream. We're talking about a closed-loop revolution that is already happening, and it's all being powered by some seriously impressive technology.
In fact, things are moving way faster than most people realize. You're going to want to keep an eye on the year 2026. Experts are pointing to it as a major tipping point, the moment when a lot of these circular technologies and, importantly, new regulations really start to hit the mainstream.
So how do we actually pull this off? How do you turn these mountains of garbage into something valuable? Well, it all starts by getting very, very smart about sorting it. We're talking about pairing the power of artificial intelligence with a physical world of atoms.
And let's be honest, this has always been the Achilles heel of recycling, right? I mean, if you've ever stood over your recycling bin holding a yogurt cup and wondering, wait, should I wash this? Does the lid go in? You get the problem. Now just multiply that confusion by millions of tons of trash. How could any system possibly sort through that mess?
Well, the answer is you build a superhuman system. Here's how it works. First, as all that trash flies down a conveyor belt, powerful optical scanners read the unique signature of every single item. We're talking milliseconds. Second, an AI brain takes that data and instantly identifies what it is, the exact type of plastic, the color, everything. And finally, guided by that AI, a whole team of hyper-fast robotic arms shoots out and sorts everything with a speed and precision that is just, well, it's not human.
Okay, so the AI and robots have solved the sorting problem. Awesome. But that just brings us to the next big challenge. With plastics, the old way of recycling, what we call mechanical recycling, isn't really recycling at all. It's more like downcycling. Every single time you melt a piece of plastic, its quality gets worse and worse until it's basically useless.
And this chart really shows the leap forward. The old way, mechanical recycling, is just a crude melting process. But the new method, chemical recycling, is so much more elegant. It's a chemical process that doesn't just melt the plastic. It actually deconstructs it, breaking it all the way back down into its original, pure molecular building blocks. It basically unmakes the plastic.
And the result of this? It's a total game changer. With chemical recycling, you can take an old, grimy piece of plastic waste, break it down to its fundamental molecules, and then build it back up into brand new plastic that is absolutely identical in quality to plastic made from oil. And you can do this over and over and over again, forever. It actually, finally, closes the loop. All right, so we've got the smart sorting, we've got the advanced chemical processing, the technology is amazing. But there's still a missing piece of this puzzle. For the whole thing to work, the system needs to know exactly what it's dealing with. It needs information. I mean, think about your smartphone. It's not just a piece of plastic, right? It's this incredibly complex sandwich of glass, dozens of different metals, polymers, glues. The same goes for a fancy winter jacket. The AI sorter can see the outside, but how does it know what's hidden inside? How does it know how to take it apart? The solution is surprisingly elegant: data. We're going to start giving every single product its own digital birth certificate. It's called a Digital Product Passport, or DPP. And it's basically a unique data file that follows an item around for its entire life, from the moment it's made to the day it's ready to be recycled.
And nope, this isn't just a theory. The European Union is already making this mandatory for things like batteries and clothing. It's as simple as a QR code on the tag, but it's backed by secure blockchain so you know the info is legit. When a recycler scans that code, they don't have to guess anymore. They get the product's full ingredient list and even a step-by-step guide on how to take it apart. It changes everything.
So let's recap. We've got the AI sorting, we've got the chemical recycling, we've got the data passports. The technology to make this all work is basically here. Which brings us to the final and maybe the toughest hurdle of all. It's not about engineering anymore. It's about business.
Because look, the tech can only do so much. If a company designs a phone with the battery glued in so you can't replace it, or uses weird proprietary screws so you can't open it, well, then even the smartest robot in the world can't recycle it properly. The real fight has moved from the recycling plant to the product designer's desk.
And this puts two totally opposite philosophies on a collision course. On one side, you have this idea of design for disassembly, making things modular, repairable, easy to take apart. The goal is long-term value. But on the other side, you have the model that's made a lot of companies a lot of money. Planned obsolescence, designing things to fail, glued shut, unfixable products where the real goal is just to make you buy the next one.
And that leaves us with the ultimate question. The technology for a truly circular, waste-free world is here. The data systems are here. The only thing left is a choice. Are companies finally going to embrace designing products that last, that can be repaired, that can be part of this new circular world? Or is the short-term profit of making disposable stuff just too hard to give up? That's the decision that's going to define the world we live in.